To build the entire chip composed of 80 different layers, it takes 3 months of traveling from tool to tool, where at each stop, one of the 940 process steps is completed. In order to increase the microchip mass production capabilities of a semiconductor fabrication plant, or fab, typically there are dozens of the same semiconductor tools organized in rows that perform the same process. On the clean room floor, there are a total of 435 semiconductor tools, resulting in the fab's production capacity of 50,000 wafers, or 11.5 million CPUs a month. These tools have rather complicated names, so we'll start by categorizing them according to their functionality. There are 6 groups: making the mask layer, adding material, removing material, modifying the material, cleaning the wafer, and finally, inspecting the wafer. We've color-coded the different functional groups to the various tools and process steps to help you not get lost. Let's next look at each of these semiconductor tools and see how they process the wafer in various ways. We'll start with the ones that are used to make the mask layer, or the nanoscopic stencil on the wafer. These tools include the photoresist spin coater, photolithography tool, developer, and photoresist stripper. First, the photoresist spin coater applies a light-sensitive layer to the surface of the wafer and sends it through a soft bake, where the wafer is heated in order to evaporate the solvent from the photoresist. Next, the wafer goes to the lithography tool, which shines UV light through a stencil, which is technically called a photomask. The light passes through the stencil and is then demagnified or shrunk down to produce a nanoscopic pattern on the wafer. Wherever the light from the stencil touches the wafer, the photoresist is weakened. The wafer then goes to the developer, and the weakened photoresist is washed away, leaving only the patterned nanoscopic stencil on the wafer. The wafer is then sent through a hard bake to harden the remaining photoresist. Next, the wafer travels to other tools to undergo processing. And once these processes are completed, the wafer goes to a photoresist stripper, which uses solvents to dissolve and remove the photoresist mask layer. And that's how a mask layer is formed and then removed.